Hello! Hi guys, today's August 27th and we're going to talk about section 1-2, properties of real numbers. By the end of today, hopefully you'll be able to categorize real numbers and complete a card sort on Desmos. Let's get started. We're going to talk about real numbers. Basically, any number that you can consider would be a real number. And a real number, it has a symbol. It's a letter R, but it's kind of a fancy R. It has like a stripe through it. An R with a stripe through it, like that. Within real numbers, you'll have to realize that there's many different types of real numbers. There's irrational and rational. Let's first talk about rational numbers. Rational, within the word, you can see ratio. A ratio can be written as a fraction. So basically any number you can think of that can be written as a fraction, such as 2/3 or maybe 1.5. I could rewrite that as a fraction. So fractions, decimals, even whole numbers can be written as fractions, like 5/5. I could rewrite that and notice it's a whole number, or 25. Even if these numbers were negative, they would still be rational because they could still be written as fractions. Some irrational numbers would be numbers like pi. That number is 3.14159, and it continues and continues, and there's no pattern to it, so there's no way I could really create a fraction out of pi. Also, I could think of the square root of a non-perfect square. A perfect square is like 4. The square root of it's 2. Or 9. The square root of it's 3. But a non-perfect square is something like 2. What's the square root of 2? It's a wacky number, and it just keeps going on and on and on, and it has a decimal with no type of pattern to it. That would be irrational. But there's no other types of numbers. Once it's irrational, there's no other categories for it. But within rationals, which I could symbolize with the letter Q, it's really a fancy Q, there's many types of rational numbers. First is integers, which those are my positive or negative whole numbers. So I can do like -2, -1, 0, 1, 2, and it could continue. They could be positive or negative whole numbers. Or I could just symbolize it with the letter Z. A fancy Z, but a Z nonetheless. Whole numbers are like integers, but it kind of excludes some of the integers. They start at 0 and they continue only in the positive direction. 1, 2, 3, and so on. And then finally, natural numbers. When I think of these numbers, I think, what was natural when you first started learning how to count? Well, you started counting with 1. 1, 2, 3, 4. So it's very similar to whole numbers, but it does exclude the 0. And for whole numbers, our symbol would be W. And then for natural, our symbol would be N. And it's kind of a fancy N. So we're going to go ahead and classify some numbers. I'm going to really quickly write those names and their symbols. So there's real, there's rational, there's integers, there's whole numbers, there's natural numbers, and then there's the funny one, there's irrational. And they all have their letters R, Q, Z, W, N, and capital I. So let's look at this. -23. What we're working with for our purposes for now, we'll always have real numbers. So all of our numbers will be real. So I have to decide, is it rational or irrational? So I think, could I possibly turn -23 into a fraction? Of course I could. I would just put it over 1. So that would also be a rational number, which would be a Q. Next, is it an integer, a positive or negative whole number? Of course, it's a negative whole number. And whole numbers start at 0, so not including negatives. So this would be real, rational, integer. When I look at the square root of 16, I'm thinking, what does that actually reduce to, or can I even reduce it? Well, the square root of 16 is 4, because 4 times 4 is 16. So really, I'm working off the number 4. 4 is real. I kind of told you already, for our purposes, everything will be real right now. This is properties of real numbers. It will be rational. I could definitely turn that into a fraction. Is it an integer, positive or negative whole number? You bet. Whole number, because it's positive. And then a natural number, because it's one of those beginner numbers that we used in elementary school. Then finally, we're down to example C, which is -4/9. All the numbers are going to be real. So next we have to think, is it rational? Could I create a fraction? Well, yeah, it already is a fraction. And could I make an integer from this, which would be a positive or negative whole number? And no, we could not do that, because no matter how I try to reduce this number, it's just going to say -4/9. I couldn't make it into a positive or negative whole number. So it would just be real and rational. What we're also going to talk about today is the order of operations. You've probably done some of these problems before, and you might have called this order PEMDAS. I've even heard some people say GEMDAS, but P would stand for parentheses. And then the E would stand for exponents. Where many students get confused is this MD. It stands for multiplication. Multiplication. I'm having an issue here. I'll try to figure it out. Or division. It really depends on what comes first in the problem that you're simplifying. It doesn't necessarily mean that multiplying always comes before division. That's not true. And finally, kind of the same thing happens with addition and subtraction. It doesn't necessarily mean that it'll always be addition first. It means you just go in order from left to right. So I'm going to put add and subtract. So let's look at this first example here. I'm going to start with parentheses. I have a set of parentheses here and a second one at the end. The one at the end doesn't have any operations actually happening within it. So this is more so multiplication. Parentheses, it means that I'm going to figure out something inside a set of parentheses. So 5 minus 3 is 2. So everything else I'm just going to bring it down. 20 divided by 2 plus 5 squared times 3. If you don't like times written that way, you can put a time symbol. That's up to you. Next, exponents. I have a 5 squared here. Exponent is a number times itself, however many times that exponent says. So this is 5 times 5 is 25. So everything else I'm just going to bring down. 20 divided by 2 plus 25 times 3. And this is that part that I was telling you about. Notice I have division and multiplication on this next step. Just go from left to right. So I'm going to do the division first. So 20 divided by 2 is 10 plus 25 times 3 is 75. And then finally add them together to get 85 for my total. Be careful with that. Let's look at the next one. I'm going to start with parentheses. I don't actually have any operations happening in the parentheses. So the next thing I'm going to do is exponent. I noticed that there's a couple of exponents here. On the top of this fraction, I have 8 squared, which is 8 times 8, 64 over 4. Minus -1 squared. -1 is -1 times -1 is +1. But notice that negative right there comes from the negative that's already involved. Plus 4 times -9. Now let's see, we already have taken care of the parentheses and exponents. Now multiplication and division. Remember, just go left to right here. So I have division here. 64 divided by 4 is 16. Plus minus, we can really just say minus. And then right here, I'm going to say negative 36. And then again, last step, addition and subtraction. Let's just go left to right. 16 minus 1 is 15. 15 minus 36 is negative 21. So my final answer there would be negative 21. Finally, we're going to talk about the distributive property, which is another way of multiplying. So I'm going to multiply what's on the outside of the parentheses by what's on the inside of the parentheses. So 3 times 4x would be 12x. 3 times negative 2y is negative 6y. And I'm going to do the similar process on the second set. Negative 2 times 3x is negative 6x. Negative 2 times y is negative 2y. Anytime you get a problem and you notice, hey, these have like terms, go ahead and combine them together. So 12x minus 6x would be just 6x. And then let's combine the y's. Negative 6y minus 2y is negative 8y. So that's my final answer. And finally, on the last problem we're going to do together today, I'm going to distribute 5 times 3a is 15a. 5 times 4b is 20b. And then let's distribute the second parentheses. 7 times a is 7a. And 7 times negative 2b is negative 14b. Again, let's check. Are there any like terms, anything we can combine together? Let's combine these a's with a's. 15 plus 7, we have 22a. And then let's combine the b's together. 20b minus 14b is 6b. And then we're done with that problem. Thanks. That's the end of our lesson today.